Carbon sequestration is the transfer of carbon dioxide into the soil. You can understand carbon sequestration thinking about inputs and outputs, like your checking account balance. Money that comes in needs to be greater than money that goes out to maintain your balance. So there's a couple different ways we can measure carbon sequestration. One is to measure soil over time. So you can go out, you take soil samples, and then maybe in 5 years later you come back, you measure it again. The problem with that is that soil's very patchy, so you have to take hundreds of soil samples to do this. And processing the samples and the laboratory analysis is very time-consuming and expensive.
Carbon sequestration is not simply the capturing of carbon by plants, but it is turning the carbon captured by plants into permanent carbon in the soil. And that happens by a number of different processes. One of them is root growth of plants, and so we know very clearly that plants that put roots down deep into the soil sequester more carbon. Another big part of that is understanding what we call the microbiome of the soil, because even with the roots going down into the soil, we know that the carbon does not stay in the soil unless it is essentially reacted with a microbial community. Bacteria, fungi, viruses, those types of things in the soil are converting that carbon from something that can easily escape into the atmosphere into something that is far more permanent and ends up being permanent in the soil. And that's when it becomes sequestration rather than just simple photosynthesis.
Studying the soil microbiome is one of the next frontiers on the ranch, and it's really sort of an unknown ecosystem below ground. We do know that the pasture type affects the soil microbiome. So for example, there's much more bacteria in the soil in improved pastures compared to more fungi in the soil in semi-native pastures.
The soil microbiome is important in this whole story. It is literally the heart of carbon sequestration. We talk about the Cusick paper and the fact that we have far more to gain by enhancing sequestration than we have by trying to add feed additives to a system. This is really critical because the microbiome is at the heart of sequestration itself. We want to understand what properties of that microbiome make it sequester carbon, and can we use the microbiome as a metric for understanding how much carbon sequestration is actually happening in that case. So that's why we're focusing so in depth on the microbiome side of the story. What's being measured when we look at the microbiome of those animals is not the activity of the microbes themselves, but we're looking at the composition of the populations in that microbiome. And this is what we do in animals when we're studying the gut of animals, or indeed humans. The composition of that bacterial population or that microbial population will typically tell you a lot about what functions are going on in that population. And the research that we're trying to do is trying to relate the composition of the microbiome with the function of sequestration and putting the two together.
I do think there's an interesting win-win situation here for ranchers and carbon sequestration, because typically the practices that improve carbon sequestration also improve forage production. So things like irrigation or rotational grazing, legume integration, all of those things increase productivity. We have to consider the emissions and the uptake by the land and how our management practices affect that carbon sequestration, because all grazing is not equal. Well-managed grazing systems have the ability to sequester carbon. Overgrazing has a negative effect on carbon sequestration.
So looking into the future for the research at Buck Island, I think a lot of it is focused on trying to develop things to apply the Buck Island model to the rest of the world, right? Because we know that carbon sequestration interventions do not work the same everywhere. Although there is a meta-analysis out there that says the average intervention is almost 50% reduction, there are farms where it doesn't work. And so the hope for the future is that we develop models that are robust enough at Buck Island that we can apply them to actually understand carbon sequestration at locations all around the world.